Uh, Good afternoon, everyone. Welcome to day 6 of this CySER summer workshop. I am very excited about this afternoon. I am traveling, as the rest of the audience knows. I'm in the East Coast. I will be moderating this, but I'll be joined by my colleague James, who would be monitoring things in Pullman, and he would be also asking questions, several of them later on. But we are super excited about this afternoon. We have a unique set of things so far in the workshop. We have had presentations, we have had visits to 2 different places and one upcoming, but we didn't have a chance something like this one. So this will be unique, something new to the workshop we're doing this year. So I'm going to be leading this. First, I'll introduce who the panelists are, and then you'll get a chance to introduce yourself a little better. We did ask students questions that they would like panelists to address, and they did a good job responding to those questions. And so the questions James and I will be asking will be fielded from there. And as the conversation goes, if there are questions students have, you're welcome. It's not too late, and James would be monitoring that and give you a chance to ask. But that's how it would go. So we've got 2 categories of questions. The first set I will ask, and then James would ask you the other remaining questions from this other category. So our panelists today, we've got 5 of them from different places. The first one is Jason Lee, who is the Chief Information Security Officer at Splunk, WSU alum, I may add. And so that will be our first panelist. The second one is Dr. Matt Rivoli at Montana State University. He's a faculty member there, an assistant professor, but I've had a long career before in industry, and one of the reasons why he is here in this panel. The third guest, who is the only one in person there, is Dr. Jessica Smith. She is a senior cybersecurity research scientist at PNNL. The fourth one is Andrew Ginter. He is the Vice President for Industrial Relations at Waterfall Security Solutions. And we have Timothy Weaver from the Air Force Research Lab, an electronics engineer there. And he's also the Deputy Viceroy Program Manager representing AFRL at the, where this program is born in. Out of this, we have had Matt and Andrew gave seminars in the CySER seminar series this spring, so it's very nice to have you back on now. And so these are our panelists. I will start off with question asking you to basically introduce yourselves and your roles, and there will be several other follow-up questions. So I will go in the order. I have just introduced you, so why don't you get started, Jason?
All right, so happy to be here, and go Cougs, of course. So let's see here. I'm the Chief Information Security Officer here at Splunk. A little bit about my career. So I started at Microsoft, worked there for about 15 years, and had all kinds of different jobs. Probably one of my most fun jobs is I ran security for Xbox Live and Xbox itself. So was in the gaming area for several years. Also had all the cryptography within Microsoft. That was all in our product. So I went from gaming to super technical into cryptography, had a lot of fun there. Went over to Salesforce to work to a kind of a cloud-born company, and then went to a little startup called Zoom right before the pandemic. That was really interesting timing. And then it was pretty crazy. And then I've been here at Splunk for about 2.5 years now. And we were just purchased by Cisco like about a month ago. So we're just kind of working that out. So pleasure to be here, and happy to talk to everybody.
Thank you very much, Jason. Matt, I introduced you next, so why don't you go and introduce yourself?
Sure, thanks, Asma. Yeah, so my name is Matt Revell. I'm an assistant professor at Montana State University. I just started this past fall. And my research, both before joining the university and since then, is continued to be automation for vulnerability discovery and reasoning about vulnerabilities, namely, and then some other related tasks as well. So before coming to MSU, I was a principal investigator for a company called Kudu Dynamics, doing some work with a couple organizations, including DARPA. Yeah, so my history has been back and forth between academia and industry. So if you are curious about switching back and forth, I'm happy to talk about that.
Perfect. Thanks, Matt. I'll go to you, Jessica, next. Why don't you introduce yourself and your role right now?
Certainly. First of all, can everybody in here hear me? Since I don't have the wonderful speakers. Awesome. All right, I am Jess Smith. I am officially a senior cybersecurity research scientist, which means I kind of get to do what I want, which I love. But I have some pretty strong ties to the region here. Vandal for my undergrad and my master's degree, and then a Coug for my PhD. Came back over here. They said you don't want to get all your degrees from the same university. So I went 7 miles over the border. Didn't work. Since getting my degrees, I've worked a pretty broad array of places. Worked back in DC doing direct government service for a bit. I did go through the Scholarship for Service program, if any of you are familiar with that. So I did have some government service that needed to happen. Afterwards, I came out, I've been at P&L for about 7 years this time. I was there for about 3 years. A bit ago, worked in industry here at CySER Engineering in the middle. I've also worked places like NASA, a little bit of experience there. So I've got a little bit of time at just about everywhere. I like where I'm at. I like the national labs because we're a weird mix of industry, academia, and pure research government support. Trying to go out, what else I can tell you? I am here local. I actually live about 20 minutes north up in Palouse. So if you ever get bored and you want to come out to a Podunk town, give me a holler and you'll come to the one town or the one restaurant in Palouse. Back over to you.
Thank you very much, Jess. We appreciate that you're there in person and glad to have you here. I'll go to Andrew next. Andrew, why don't you introduce yourself?
The plague of the pandemic. Andrew, you're on mute. Yes, thank you. I'm Andrew Ginter, VP Industrial Security at Waterfall Security Solutions. I've been with vendors pretty much all my career. I bounced around as a youth. The grass was always greener, and settled in at Hewlett-Packard, developing high-end industrial control system product. This is the technology that automates the world's largest petrochemical pipelines, the world's largest power plants. It was our niche was the high end. I moved from that into, the thing to do in the mid-1990s in industrial automation was connecting automation systems to business systems, in particular SAP. So I wound up leading a team developing a technology, a product that connected lots of different control systems to SAP, thereby connecting a great many operations networks to IT networks and contributing to the cybersecurity problems that now plague many industries. In a sense, I got religion. I wound up Chief Technology Officer at Industrial Defender, developing the world's first industrial SIM. And now I'm with Waterfall, coming up on the end of my career. I had the opportunity to work with, talk to, learn from some of the world's most secure industrial sites. Again, Waterfall serves the very high end of the security market, the most consequential industrial automations. Think nuclear generators, high-speed passenger rail switching systems. And as I said, learn from them. I've written 3 books. I contribute to standards and try to provide some value, offering advice and learnings back into our prospective customers, our existing customers, and of course the industry at large.
Thank you very much, Andrew. And on that note, we have shared the book that you generously sent out to students after your seminar. And some of the students in the audience might have read that book. I have heard some rumors that they were having it in their hands when they were going to one of these field trips recently. So thank you for the introduction. Team, I'm going to let you introduce yourself at AFRL and your connection with Viceroy.
Sure. Yeah. So I'm the Deputy Program Manager for Viceroy. Mostly my role is developing and running the intern program that we have for 8 weeks over the summer here, as well as recruiting students for the program. It's a long way from where I started. I started out as a civil engineer. I worked in that field for about 20 years and I just decided it was time for a new challenge. So while I was doing that job, I pursued my electrical engineering degree. And I've been with the Air Force Research Laboratory for about 10 years. I've done various different areas here. I've done software-defined radio. I've done simulation and modeling. And so for the last about 6 months, I've been the deputy program manager for Viceroy. Over.
Thank you very much, Tim. So these were wonderful introductions from you, and the sort of questions we got, we would kind of try to put them together as needed. But one of the things that came up from several students was related to how you got to where you are now. Was this like a goal you had in mind to be in cybersecurity? Or was it something that you just happened to be there and it evolved? And I think from your little introduction so far, there's a little bit of a hint. But if we started there, how would you say for that particular questions that students have? And I'm going to go start with Jason this time also.
Sure. So let me start about in college. I didn't plan on going into computer security or cybersecurity initially. I started in finance and then switched over to MIS. And it was, I think, the first year that they had MIS at Wazoo. But kind of when I was in my finance degree, my family didn't have a lot of money. I loved video games. And I learned how to basically taught myself how to crack video games. So, don't tell many people about this, but so I learned how to kind of was getting really interested in how the software works, how licensing worked, all that kind of stuff. And then happened to be good enough at that got a job at Microsoft after I switched over to MIS. And I started my career in attack and penetration, which was basically breaking into, mostly it was like web apps, things of that sort of nature, but have always kind of moved into a whole bunch of different jobs in security. I just love kind of the career space and was lucky to fall in literally right off the bat into something that I enjoyed. I like to tell people that cybersecurity is not a problem you can solve. It's like a puzzle that has no end to it. And so I like those kinds of challenges where there is no right or wrong answer really, and you're trying to do the best that you can. And didn't ever intend to be a CISO, which is kind of like the top level of in your career, but it's been a lot of fun, and I really enjoy doing it. And you get to meet kind of people from all kinds of career paths. I've had people that were pen testers that had philosophy degrees that were just able to break into anything. So it doesn't necessarily, I like to see that kind of diversity of backgrounds in the cyber industry. And so I've had a lot of fun with it, and really enjoy kind of the whole career space.
Thanks, Jason. I'm going to go to you, Jess. And I know you mentioned you were an SFS student, and WSU is attempting to get one of those, and you will be the first to hear when a positive thing comes out of it. And so that might give me a clue. But why don't you take that question? How did you get started? Was it like something you had all along with your mind, or something you ended up being there? So,
sure. I fell into this. I did not go into this planning at this. I went into a computer science, computer engineering specifically degree, because my husband had been military, and I worked at every little computer repair shop outside of every port on space you can think of. Fort Polk, Louisiana, Fort Carson, you name it. And I was sick and tired of fixing computers that were poorly designed. I wanted to make a better computer, something that was actually easy to fix. And so I was going through my classes and just getting through. And this crazy guy by the name of Dr. Alex Foss, who might happen to be sitting in the back of the room right now, said, "Hey, Jess, come take this class. Hey, Jess, we've got this scholarship program." And at that point, we were on the old GI Bill, which is $1,000 a month. That covers your housing, that covers your schooling, that covers your food, that covered everything. So SFS, the scholarship there, gave me an opportunity to get my master's degree, to continue my education, to not be in tons of debt. So that was kind of how I fell into this, was just Jim said, hey, I think you'd be interested in this. I think you'd be good at this. He was extremely right. And then I went from there to looking at power grid. How do we make the power grid more secure? And that was what drew me down the path into a PhD in computer science, a PhD focused on cybersecurity. Was, okay, I want to know how to trust the equipment I'm putting into the power grid. How do I know that the integrated circuits, the laptops, the desktops, the monitors, at that point we weren't connecting cell phones in just yet. But how do I do that? Because I really want the lights to stay on. I like my gaming machine. I like the internet. I like all of these things. So how do I make sure they don't fail? And that was what ended up leading me into my PhD, was some novel research I was doing in reverse engineering integrated circuits. And from there, it's just been a heck of a lot of fun.
Thank you very much, Jess. I'm going to you, Andrew. And
Yes,
because
please.
Yeah, and so there is a connection there, and you want to talk about industrial control systems as well. So why don't you tell us your story there?
Yeah, I wanted to take actually a different tack. What I gave you a moment ago was the sushi version of my background. Okay. I worked for HP 30 years ago. Back in the day, they had a reputation of being, the business that produced the most amazing technology, and they weren't able to market their way out of a wet paper bag. They were accused of selling sushi as cold, dead, day-old fish. Technically accurate, but not very appealing. Here's the cold, dead, day-old fish version of my background. I signed with HP. I did grunt work. I did the work nobody else wanted to do, but was important to the business, and they promoted me. I became indispensable. Okay. HP got focused and spun us off. I'm still sitting in the same cube. Now I'm working for Agilent. They wanted to do this integration thing and said, Andrew, you're a project lead. We promoted you for a reason. Take this over, make it happen. So I did. Agilent got focused and spun us off. Verano bought us. They were a no-name venture-funded startup and ran out of runway. They canceled. They obsoleted all of our product. None of it was being sold anymore. Funny thing is, people kept buying it. The receivers came in and said, where's this money coming from? So we did a reverse takeover. We became Verano, still sitting in the same cube. The opportunity, we brought in Brian Ahern from the industrial space as a CEO, and he identified the opportunity as cybersecurity. This was just after 9/11. So I'm sitting there and I said, Andrew, develop for us mandatory access control into our control system, because we're porting it to Linux. Sold 0.0 of them. Clearly the wrong solution. But then, the next thing was, fine, then let's build a SEM. And they rebranded to Industrial Defender. The CTO left. They said, Andrew, you seem to know what you're doing. Can you be our CTO? I said, sure. So I'm still sitting in the same cube. Okay. And eventually, we consolidated. I moved all 4 development teams into the same office in Boston and waved goodbye, because I wasn't going to move to Boston. I signed with Waterfall, and the rest is history. But that's the cold, dead fish version. It's not like I planned it. And what I encourage all of our listeners to do is, you're going to have a trajectory in your career. Develop a sushi version of that.
Thank you very much, Andrew, for that sushi analogy. And I'm going to go to your team. Maybe there is something that would also sound like you started off somewhere else and ended up where you are now. So you may tag on to that and give us your version.
Sure. I'm being the deputy program manager now. 10 years when I started with the Air Force, I never would have thought I would have been into program management. So when I started 10 years ago, they kind of give you a talk about how there's 2 ways your career can go. You can go the technical side, or you can go the program management side. And I thought then, forget program management. There's no way I want to do that. You can just put me in a dungeon and I'll program in MATLAB all day and I'll be happy. So I've done that, minus the dungeon, but more like a room with no windows. And I really didn't like that. But I know one day, my boss came to me and he said, hey, I got this great opportunity. we have a contract that needs somebody to management. Like, do you want to give that a try? So I tried that, and one after the other would come along, where more opportunity, as they like to call it, where you can add more contracts. And every time I would happily take it. And I just found that I really enjoyed the program management side. And it's just funny. I mean, it's, you know, it's in your career, you're going to have good and bad experiences, but I feel like you learn something from all of them. And it really, and by having that experience of doing the programming all day and not enjoying it, I found not only what I didn't want to do, but I found what I wanted to do.
Thank you very much. Matt, I'm going to conclude with you this same question about how you ended up being here, and you are unique from this set of panelists because you came from industry to academia, and so you may want to comment on that one as well. But I wanted you to wear the hat of an industry person today, and that's the reason why you're here. So why don't you tell us about that?
Sure. Yeah, so for me, it was, I think, dabbling in security, kind of similar to Jason, when I was a youth, and then kind of went to college, started off in political science, then realized I like computers. I can major in the thing I like. That's okay. In my mind, I thought you had to do the thing that was work. You had to major in the thing that felt like work. Then I kind of worked as a software engineer for a while, and it was probably a decade later is when I started getting back into security, just kind of reversing things, looking for vulnerabilities, mainly binary analysis. And then to tie it in with academia, it was I kind of went back and forth, went to get my master's after taking several years off. That was great. Went away for a little bit, then went back to get the PhD. And then being a researcher in industry is actually great. And enjoyed that a lot. You get kind of you get sort of a different, you have a fair amount of autonomy in terms of deciding what you want to go after. Not as much as you do in an academic setting, or in a university setting specifically. But I guess you could say I kind of like, I didn't realize there was this entire industry where you could make use of like vulnerability research and reverse engineering skills until, like I said, about 10 years after graduating from undergrad.
All right. Thanks very much, Matt. So I'm going to ask one more question, and maybe in the interest of time, I'll give it over back to James, who would be asking about skills-related type of questions. But the question that several students have asked is, what advice would you give to someone who's just getting started in cybersecurity? So you've had your own pauses into where it ended up being a major thing you do in your career. But those who are just getting started, what advice would you give them? And this is coming from students in the CySER program. Most of them are computer science. But then we also have people who, Jason, are from the MIS program and are pursuing one of the certificate programs there. So for a variation now, Jess, I will start with you. What advice would you give to somebody who's just getting started with cybersecurity as a student?
Was that directed at Jess or Jason?
Yeah, Jess. Sure. I said Jess, but yeah, so I'll come back to Jason.
I probably have two pieces of advice. The first thing is right now, you're getting to the point where you know just enough to be dangerous. Learn more. Don't say, oh, well, I just wrote code, so I'm just going to learn to code. Or I just like networking, or I just like project management. Right now, you're in a spot in your career where the more skills you can get, the more breadth you can get, the more valuable you are to an employer. Because I can hire coders, I can hire network people, I can hire reverse engineers. But if I can get somebody in cybersecurity who knows all of those, they're going to have a much more complete idea of what risk actually is to the system. What are the threats to the system? How might an attacker exploit the system? When you get pigeonholed into a little box and say, okay, well, I'm just going to focus on this, That is the exact opposite of what a cyber attacker will do. Cyber attacker looks at the connection points. Cyber attacker tries to go underneath. If you're working in an object-oriented language, well, then they're going to cut down, then work in just a basic x86 style language. They're going to keep going under. So knowing as much about computing at large, and I would expand that. If you're thinking, hey, I want to go do control systems, you've heard that a couple of times. Go take some EE classes. Learn power. If you are going into something and you're thinking, well, I'd like to do cyber and bio, some kind of medical type of environment, which is right now very, very hot. Great. Go take some basic anatomy classes. Learn how those people speak. Because when I walk into a room and I talk to power operators, or I talk to somebody who's got a nuclear power plant, if I'm not aware of how they think and what their priorities are, I, as a cybersecurity researcher, I'm not going to do them any good. We've seen that before. Early days of the power grid getting hacked, there were some incidents when actual power grid control devices got hacked. Thank God there was no problems here in the States, but the FBI was called. And the FBI came in and they're like, great, crime scene. We know how to deal with crime scenes. All of this is evidence. And the power grid operators were like, hold up here. You take this out, you turn the power off. We need these to keep the power going. And there was a lot of friction there. And for a good while, the FBI actually found themselves a little bit shut out of those partnerships, those interactions with the power grid, because power grid operators were like, heck, I'm not going to report there's been a cyber attack, not if they're going to come take all my equipment. So make sure that as you're going through your careers right now, learn as much as you can, be as broad as you can, and learn those languages. So that's piece of advice number one. Piece of advice number two, take stuff apart. Don't just be a computer user. Figure out how it all works. And that can be literally taking apart or building your own desktop PC. That can be repairing your cell phone. That can be networking your house, setting up your Wi-Fi, getting a security appliance in there, setting up a good network. Whatever you're doing, take it apart, figure out how it works. Both then you can fix it when it breaks, because it will break. It always breaks. But also then you understand your own risk. You understand how your system, whether it's your home network, or say you're working somewhere in an IT shop, a CSOC, and you're managing a corporate network. You understand that system. You know how to put it back together. You know where its weak points are. You cannot defend what you don't know even exists. So those are my two pieces of advice. Learn everything you can right now and take stuff apart.
Thank you very much for those great advices. Now I can come to you, Jason. So time for you to give you advice.
No worries. One of my favorite things, advice I have, is looking at internships is definitely a great way to get experience into a range of different areas. Microsoft has usually like thousands of security positions open at any given time, especially in the from an intern perspective. The other thing that I also really challenge people to do is to go to conferences. There's actually like there's Seattle B-Sides. And I know there's one in, I think there's one in Idaho as well, where it's a really interesting technical conference, security conference, where you can learn kind of what are all those types of jobs, what kind of things are out there, and how you want to understand, what if that's the type of work that you want to get into. And then networking is also super important, because you can find out about jobs, who is hiring the entry-level jobs, and getting into your first like corporate job. It's so much nicer to have somebody that is there. Probably one of the easiest things to do is you ask somebody, like if you on LinkedIn, somebody's in an interesting role or at an interesting company, be it gaming or whatever, is to reach out to them and say, can I buy you a cup of coffee and chat for a few minutes? Not many people will turn that down, believe it or not. It's just like, yeah, a student learning, like a lot of us will give that 30 minutes of time to be able to chat and talk about what we do and how we do it. So I would encourage you to think about that. on the networking side. And then one of the things that stands out that gets kind of buried in the technical space of kind of cybersecurity is the more you're good at the business skills, like soft skills, presenting or writing. I always tell my chief of staff, I'm like, the highest grade I got in college in English was a C, so I'm a horrible writer. And it took me a long time to work on that, but that really sets you apart, is to be able to have that good like business writing or presenting. I used to be terrified of presenting. And so those are just a couple of things that I think can help you along your way.
Thank you very much, Jason. And it was good that you touched on the networking question. That was a separate category questions I've asked it, so it was nice to tie that in. Andrew, I'm going to go to you. What advices would you give to somebody who's getting started in cybersecurity?
I would echo, first off, Jason's advice on writing. You know, when I started in the industry, I was writing code. And, you know, bluntly, I spent as little effort as I could in English in high school. I just tried to avoid that whole space. I said, that's not me. I'm going to go do something else. Not realizing that it doesn't matter if you take the management path or the technical path, the more responsibility you're given, the bigger a team that you're working with. And I'm sorry, these are people, not machines, and we have to communicate. It doesn't matter if it's a PowerPoint or an email or a requirements document or a bit of technical design. You've got to communicate. So I would encourage people to practice writing. You know, if it's in you, I don't know, start a blog. What would you write about? Write about stuff that you learn. If you just learn something, odds are someone else wants to know that too. And, you know, it's an excuse to get some experience. A second piece of advice is, you know, I said it a moment ago, don't be afraid to do the dirty work. Do the work that nobody else wants. You know, I was working in a development organization, and I got, you know, someone had to lead the effort to get us ISO 29,000 certified. Oh, who wants to do that? That's all paperwork. I said, fine, I'll do it. You know, someone has to maintain the most critical components of the system because everybody else wanted to do the really sexy work of developing the new components of the system. I said, I'll take that. And became the expert on the quality system, developed the quality system that everyone else used. You know, became the expert on the critical parts of the system that had been written 5 years ago and everyone else had forgotten. You know, someone had to automate our testing system because we were just spending incredible amounts of labor testing things manually every release and releasing product that had an embarrassing number of bugs in it in spite of the manual testing. So I automated that. And then everybody, you know, you become the expert because you developed the automation. Everyone else is using it. And so, like I said, it wasn't my plan. I'm suggesting make it your plan. Do the important work that nobody else wants to do, and you're going to wind up indispensable. And that's a good place to be. So there's my advice. Practice writing, because as a leader, you're going to need to. And speaking and whatever. But to me, the key skill is writing. I can teach someone to speak. I have a really hard time teaching someone to write who doesn't know how to write. And you know, do what the business needs most.
Thank you very much for those great advices. Team, let me go to you. The same question. What advice would you give to somebody getting started with cybersecurity?
To me, it's like, you know, when you're looking for work and you're in the job market, really read the description of what that job is and what you're going to be doing on a daily basis. And when we're doing interviews for interns for this summer, we love when we turn the interview around and we ask you what you want to know about the job. We love when you really dig down to what you're going to be doing on a daily basis, because that's going to be, you know, a majority of your life is what you're going to be doing here. So, yeah, I mean, that's my little bit of advice. And one other thing, though, one little thing is to be just for anything you do, and we run into this when we have interviews, be on time. And whether you know, we know things happen, but if you come to an interview even 3 minutes late and you don't even acknowledge it or apologize for it, it's like we almost instantly write you off as a candidate we're going to offer a job to. So yeah, be on time. And if you're not going to be on time, you got to let somebody know.
Thank you very much. Matt, you will be the last person to speak on this topic. Advice you would give to someone getting started?
Yeah, so I was involved in the internship program at the past company I was at, and would go to universities as well, as actually doing interviews. I think the number one thing that we looked for goes back to, I think, what Jess was speaking about, which is the taking things apart, like going down a level of abstraction, and continuing to do that. So understanding how things work. A way to do that that can be fun, depending on your definition of fun, is to participate in CTFs, capture the flag events. I mean, cybersecurity has become this very broad. There's lots of things that fit within that umbrella, and even in CTFs, there's lots of things that fit under CTFs. But things like reverse engineering challenges, vulnerability research challenges, those are all great ways to practice breaking through abstraction layers. There are challenges known as crackmes, which kind of are similar to what Jason was talking about before, but they're just challenges made specifically for practicing reverse engineering skills. The other thing is if building programming languages, operating systems, just like little hobby things, is a good way to get an idea of how something else might work. So if you're working through how do I do basic memory management, or how do I deal with lexical scoping in a language runtime, that gives you some insight into how real world runtimes that you might run across work for operating systems. And then also, since B-Sides was mentioned, I help run B-Sides Boulder. So if you happen to be going back to Colorado, June 14th is when that event is happening. So we would love to have you if you're around.
Thank you very much, Matt. So both Jason and Matt touched on the networking issues and gave a couple examples. But that was a specific question students have asked. So let me not run it through all of you, but for the ones who haven't spoken on that aspect, I would ask you. So Jess, do you have any recommendations where best ways to network in the area of cybersecurity? You can think about conferences or other types of meetings or competitions, some concrete examples for students to know about.
Sure, I'll jump in.
Okay.
Was that
Just
for
next.
everybody, or?
No, you will be the other person to be asked. So please go ahead.
Okay. It really depends on where you are. If you want to do something local, I mean, going to conferences is great, can be expensive. But before I leave conferences, when you're at a conference, don't forget conference. If you're local, if you're at a bar, at a meetup, I would encourage you to go to meetup.com and see what's local in terms of cybersecurity. But when you get there face to face, you've got to start the conversation going. And I would encourage you to sort of memorize questions like, what do you do? Because people love to talk about themselves. Get them to talk about themselves. What do you do? What project are you working on? If you can tell me, what is the challenge you're facing there? What are you struggling with? What have you learned recently? What have you accomplished recently? All of these are great openers to get people to talk about what they do. It gives you an insight into what kind of roles there are out there, and lead eventually into are you guys hiring? Do you know anybody who's hiring? Can you recommend me to anyone who knows someone who's hiring? But that's networking. But the other opportunities you have, again, meetup.com, local user groups, Google cybersecurity in your town, and consider volunteer opportunities, anything from, helping the local cybersecurity user group, teach high school kids about, or teach grandmothers about, not getting scammed online. Any kind of opportunity that gets you working with peers. Cybersecurity standards committees, this is an opportunity for sort of international cooperation, or really it tends to be regional cooperation. You make contacts, yeah, but I'm not an expert, I can't help. Yes, you can. Get in there, take notes in the meeting, volunteer as the secretary. Again, writing skills. Someone has to, they finally figured out what they're going to say about X in 3 paragraphs of the standard. Volunteer, you've taken the notes, you can take a run at the first draft of that. The experts can revise it. But the point is, there's always a way to contribute. And again, this develops relationships, and you can, use the chit chat before the meeting, after the meeting, to say, hi, how you doing? Rained last night. By the way, I'm looking for work. You use those connections in volunteer organizations as well as face to face.
Perfect. Thank you very much, Andrew. So Jess, I can go to you now. I don't know if you have heard me the question. So concrete examples of networking opportunities for students in cybersecurity, or other events, or other type of meetups.
I'm a little bit odd in that I would not tell you to go to LinkedIn, online, et cetera, et cetera, et cetera. And most of that is because I am paranoid. Too many years of working for the federal government make you paranoid. I don't have a LinkedIn account, so if you want to message me on there, you're not gonna have a lot of luck. However, I would say, join your local organizations. IEEE, ACM, I know they've got student chapters here. Those connect you in with the bigger chapters. For the ladies in the group, we got Society of Women Engineers. There's several other organizations like that. That would be where I would tell you to start. The other thing is, there's a lot of us who are alumni, or who just like coming out and talking to students. I speak here, I speak over at UI, I go to Eastern sometimes. I know there are a lot of other folks that do that, that'll come out from Boeing or from CySER or from wherever. Come talk to us. We're already out here. We're already making the effort to come out and talk to y'all. We would very much like to have you come talk to us. So if you're interested in the job at a national lab, come talk to me afterwards. I've got a stash of business cards in my purse. Happy to give you one. And then start the communications. Reach out to me and say, hey, Jess, talked to you last Tuesday at this event. Wanted to know more about this that the lab does. Great. That kind of personal connection is critical. Every single, barring the first job I got that one largely, I think, because I was an SFS student. But barring that first job, every job I have gotten as a professional has been because I knew somebody, because I was talking to somebody, because they were looking, and we just happened to be discussing it. So knowing people, I know we all go into this, oh, I just want to deal with computers. People are frustrating. People are the problem. I just want to deal with my computers and be left in peace. Doesn't work that way. The people are critical. So that's probably my best advice, is join your local organizations. Find opportunities like this when people like me are coming and talking, because you can come talk to me and say, hey, Jess, I'm looking for a job, but I want to be a hands-on network defender. I don't have that right now, but I can then start reaching out to my network. If you're a valuable enough student, and you've proven that to me, that you're actually that valuable, I've got contacts. I know the folks back at DHS or FBI who are actively looking for network defenders, and I can put you in touch with them, and I'm happy to do so. But there's got to be that initial first contact at an event like this one. And yes, I agree, conferences are great. Paying for conferences as a student, I don't know about you guys, but I certainly couldn't afford it. I would love to get to those types of things. B-sides are great, all the IEEE conferences, so on and so forth. But just getting started. I know it sounds like it's a huge first step, but take that first step, and then your network, you can leverage other people's networks through that first connection.
Thank you very much, Jess. Tim, I'm going to give you the chance for this one, especially from Air Force Research Lab perspective, or DoD generally, what are good ways for students to network?
Yeah, I mean, a lot of what has been said, conferences. One thing I would say is career fairs, but not online career fairs, more in person. Any events where you can get in person and FaceTime with somebody is a great way to do it, because we've done online career fairs for the Viceroy program, and we're actually probably going to stop doing those because those just haven't really worked out in anybody's favor. So yeah, so in person. And one thing is, part of the intern program is we practice 5-minute elevator pitches every week with the students. They come up and they give an elevator pitch about themselves and maybe some work they want to propose or what they want to do. So one thing I would think about is when you do get that FaceTime with somebody, what is a 5-minute elevator pitch about yourself, about what you would want them to know about you when they walk away from that conversation? Over.
All right, thank you very much. I'm going to ask one last question before I hand it over to James. And my question is maybe related to what your role is currently right now. If you were to imagine and look at your day, just a day, what does your day look like in terms of how it falls and what sort of things you do? And I'm expecting there will be some variations here. So let me start with Jason. Describe your day in your role now.
All right. So for some context, so Splunk, of course, is a security company. And so being the CISO, I do have external facing responsibilities too. So I'm a spokesperson as part of the job. So invariably on a day-to-day basis, I have my normal operational cadence. So I have my vulnerability management team, governance, risk, compliance. I have all those functions. It's about 500 people, and all these. I have about 13 different groups within the team, and so it's understanding if there's anything that's a challenge, a problem, things that I can help the team solve with. So there's kind of that kind of operational cadence. I also have to work with, being a public company, we have to work with the board of directors. So these are these basically executives that are representing the shareholders. And so you have to convince them that you're running a good security program and doing everything that you can so that you can't get hacked. And so having to, again, kind of working on the need to be able to communicate well and be able to write well to those. And then I'm also part of our executive leadership team. So this is the kind of the normal business of Splunk, selling, how do we drive more revenue? How do we increase profit? And so having that business context is definitely very important too, because I'm being asked to help drive business decisions. And then I do media things. So usually once or a couple times per week, I'm talking to a journalist or some of those types of things. If you do look at LinkedIn, you can definitely see I've got those articles and all kinds of stuff on there. So that's kind of at a high level what I do. It's much more of an administrative types of role. I'd say I'm much more of a PowerPoint pusher and less of a hands-on keyboard these days. It's been a while for me. I'm definitely administrative overhead.
All right, that was a great place to start. Let me go to you, Andrew. Describe your day in your current role now. How will this be like?
Sure, I tend to have two different kinds of days. When I'm on the road is very different from when I'm back in the office. I'm on the road a fair bit in this role. I've got a goofy title, but it's analogous, vaguely analogous to the Chief Technology Officer role, which is a stereotypical Chief Technology Officer tends to have a small technical team focused on outward messaging, the reputation of the company, and on understanding the market and understanding where the technology that the vendor, Waterfall in my case, produces, where it fits into the bigger picture, sort of big picture technical person. And so I speak at conferences. I met with a board of directors last week. I meet with prospective customers, understand their problems, help to propose solutions. With existing customers, take their knocks if they're unhappy with us. So that's sort of the road show. But back in the office, my cadence tends to be the first few hours is overseas calls because we're a global company. And then North American calls, and then, desperately try and catch up with all the email and follow up for all those calls that I've promised. Eat lunch, and then in the afternoon, ideally, focus on content. My next presentation, someone has to put the slide deck together. What did I promise to talk about there? We've got, white papers we put out. I'm working on one now for classifying the security characteristics of cloud systems, controlling physical automation, controlling power plants, controlling pipelines. In between, there's, like I said, there's reviews of other thought leaders within the business. My team and other teams that are focused on opening up new markets, they're putting out white papers and blog posts, and want sort of feedback on them. So that's my day. I spend it mostly talking to people, not writing the code anymore.
Thank you very much, Andrew. Just let me go to you. Describe your day.
I'm going to actually give you a little bit of my day, but more of the day of one of my junior staff members, because my day right now varies widely. This morning was mostly meetings. This afternoon, I'm coming out to talk to y'all. Tomorrow, I'm getting on an airplane, headed out to Wright-Patterson Air Force Base. Speaking of which, Tim, are you Rome or are you Wright-Pat?
I am Rome.
Okay, never mind. I was gonna say, if you were Wright-Pat, I'd come see you on Thursday. So for me, my day varies extremely widely. I might be writing a little code one day. The next day, it might be a PowerPoint. The next 10 minutes, it might be a PowerPoint. Very likely there's going to be a bunch of meetings stuck in there. I do a lot of standards work right now on software bill of materials, SBOMs. So there's standards meetings and time spent writing standards. So my day varies a lot. One of my junior staff members, though, his name is Animesh Patnaik. He's probably a little bit more of a normal. At the lab, you very rarely work on just one thing. We have multiple projects that we're all working on. Each of these projects is sponsored usually by a different part of the federal government. So right now, my major sponsors are Department of Energy CySER, the Cybersecurity, Energy Security, and Emergency Response Office, as well as Space Force. And I've got a new partnership coming online with AFRL and the JFAC. So Animesh's day, usually he's in meetings about a quarter of the time. And the remaining 3 quarters, he's dividing up between those 3 projects, putting together technical deliverables. Sometimes that's writing code. Sometimes that's doing research and writing a document. Sometimes that's, we do a lot of open source investigation, some publicly available information investigations. He's doing about 3 different projects throughout the course of his day. Now, the lab is extremely flexible. I really don't care when he gets his work done. So that could be, he's working on that at 8 o'clock in the morning, and it could be he's working on it at 8 o'clock at night. I don't really care. So long as he makes his meetings, it's all good. So that is probably more a standard day. We are not network defenders in that we're sitting there dealing with tickets coming in, dealing with monitoring the network day in, day out. We do a lot of smaller research projects that are teams of maybe 10 people who work on the same project for 1 to 3 years type of thing. That's much more our norm.
Thank you very much. Tim, your name was called on, so why don't I go to you? So this is Tim from Rome, so go ahead and tell us what your day looks like.
Well, it's a tough question to answer, but that's why I'm in program management, because it's hard to just say, what I do on a daily basis, because it does vary. It depends. Like today was meetings all day, but in general, Viceroy runs in seasons is the way I look at it. In the summer for the 8-week program, we're running the program. We're bringing in guest speakers every day that we're talking to. We're dealing with the little problems that might arise with the interns, just a lot of stuff like that. In the fall, we'll be looking at expanding the program beyond what it is now. So we'll be visiting a lot of other colleges and traveling around trying to get more students. And then we get into probably what might be half the time is reviewing resumes and interviewing students and getting our candidates lined up that are going to be taking the jobs, figuring out who their mentor is going to be, who they might work good with, who they might not. And then there's in between all that, there's just other stuff that comes up, little things like, you have to update the Pentagon or update people in Washington about how the program is going. You got to update your local supervisors of how things are going. It just depends on what comes up from one day to the next. But that's what I like about it.
Right. Thanks a lot. You will be seeing some of the students come your way now, and a few days after they are finished with this, there will be nearly 10 students coming from CySER from WC. So great to hear about your preparations for that and how you view it. Matt, you take the last word on this. Describe your day the way it is now as in academia.
Oh, in academia? Oh, okay. I was all ready to talk about how it was in industry.
You could do both.
Okay. And so in academia, so there's lots of balancing. So I know for students, right, I think I know it was for me, especially in undergrad, this perception of, my professors they're just, they're focused on the class. That's the only thing that they're doing is they might teach a couple classes. They might be fixing up slides or practicing what they're going to say during lecture, grading. But there's lots more. So it's a balance with, and this varies in different academic positions. But in general, it's usually a split between research and teaching. And so that when I'm not doing course preparation or grading or et cetera, it's some of it is actually similar to what I was doing in industry before. So keeping track of when there are new programs being announced, keeping track of what's out there. Is it interesting? Is it something I want to, try to put a proposal together for, or find other people either in industry or in academia that I want to team up with to go after that proposal. And that can be anything from like so some of the larger organizations are DARPA, which is probably the one that is most likely students may have heard of, right? So they were involved with things like the internet. And then there's other organizations like NSF, which is focused on supporting research in academic institutions. Working with students, so like undergrads and grad students that are interested in research. So that's actually been a lot of fun. So kind of like growing a lab. It's the thing that you realize, whether you're in industry or in academia, is you can do a lot more when you work with other people. And so it's less about what you're doing, and it's more about enabling the people that are around you to get things done. And then together you can accomplish way more than you could if you were tackling it by yourself. The hours are flexible. There's lots of work to be done. But other than classes and other kinds of meetings, when you do that, 3 a.m, that's okay. Let's see. I think that's it from the academic side. Industry side was similar. I guess traveling, right? So that kind of travel here and there, either to go to workshops or to go to events that are supporting where your funding is coming from. So usually that's a time to collaborate with others that are working on the same problem, or maybe in a different aspect of the same problem. I think, and then, right, whether you're in industry or academia, both before and now, putting together slides and writing papers is and anytime an idea comes down, jotting it down, right? So I try to keep a record of anything that I think has the potential to be useful, either as a thread of my current research, or if it's something that, maybe something that I suspect might be useful, maybe a year or even longer than that. A program comes out and there's a hard problem, and if I already have an idea of how that might be solved, I can use that as kind of a launching pad to start working on a full proposal.
Thank you very much. I think I will hand it over now to James. He may have some additional questions from a different category of questions that came from students. For now, I will stop asking questions. James, can you take over?
Yeah. Hi. Let's see. I think I'm in a good spot here, camera-wise. Yep, there I am. So yeah, before I start asking questions, do we have in the audience here any follow-on questions to what we've just heard? Nope. Okay, I'll get started then. So picked an easy one for my first question. It's from our pool of student questions, and that will be what programming languages are important in cybersecurity, and we can interpret that as maybe sampling from each of you what are the top 2 or 3 programming languages you've used in your careers. You can let us know your favorite one, or maybe in Tim's case, your least favorite one. So we'll start here with Jessica.
You're all gonna laugh, but it's assembly. Because I can get in underneath. I can force the architecture, I can force the computer to do what I want it to without a compiler, without some kind of translator getting there in the way. So it's either, I'm using it's either assembly, or if I'm actually needing to do something and do it quick, it's probably Python.
All right, let's see, next, just by my display here, I'll go with Andrew.
Sure. I was going to say, in my understanding in the industry at large, there's a lot of product being built in Java nowadays. And the sort of most time sensitive is being done in, to my knowledge, still in C and C++. But there's a lot of other pieces. There's web services. There's the higher you go up into the software stack, the more likely you're going to be to run into Python and the LAMP infrastructure. But I really like Jess's observation that assembly is important. I have written well, at one point I maintained 100,000 lines of assembly code in a product, but that was a very long time ago. Since then, I've written maybe 200 lines of assembly in the rest of my career. But the reason it's important in my mind is not that you write a lot of code in assembly. It's that you need the understanding of how the machine works. You need the understanding of how the operating system works. What I encourage people to do is learn how networks work at a detailed bit by bit, look at the ones and zeros coming across the wire level. If you can understand how your network works, if you can understand the assembly language, the machine language, the structure of your device drivers, if you have that detailed knowledge, that in my experience is invaluable when you're talking any kind of cybersecurity.
Great, thank you. Zoom switched up the order here, so I'm gonna have to try and remember who's talking and who hasn't, but we'll go to Tim next. I know you said previously programming is your favorite thing to do, but that must mean you've done a bit of it to know that, so.
Well, yeah, I mean, for me, it was C++ is what I left off on, but when we're pairing mentors with students, we ask the mentors, hey, what programming languages do you need? What do you prefer? The hot one this summer was Python, was the big one that all of them pretty much came back with Python. And then some of them were Java, some were C++, but Python was the big one this summer.
Okay, great. And Matt.
Cool. Okay. Yeah. So the one I use the most actually for my work. So the work that's kind of like static program analysis. So understanding what a program is doing and using that to try to uncover vulnerabilities and reason about them is Haskell. And I think it's well suited for that purpose. And I think even if you're not working in program analysis or compilers or something else similar, it's worth learning because it challenges how you think about programming, assuming you have learned through C or Java or Python. C and various, right, the various assembly languages out there are really useful for understanding what's either interacting with hardware or understanding what's happening if you're looking at compiled code. So there are some vulnerabilities that don't actually reveal themselves except if you look at the assembly level. So it is really important to understand. And then Python for machine learning things, and for kind of quick and dirty scripts to do some data munging.
All right, and Jason.
All right, I'll give mine the caveat of remember tech companies, Microsoft, Salesforce, Zoom, Splunk. So I would say in cybersecurity, pure, like in that space, I would say by far it's Python. But then in the product development side, I would say Java, JavaScript, C++, Rust is growing a lot as well. I know Microsoft has been pushing Rust big time to switch out its C to Rust. So I know they're going through refactoring there. So those ones are always good. When you think of that, when you think of a Facebook, Google, all those languages apply to all those big tech companies, Amazon. So it's kind of funny. Everybody in the industry, once you get into these kind of big tech firms, we all switch around to those same companies. And so just so happens that they're all the same programming languages too.
Yeah. All right. So I guess for the students here, don't avoid assembly. Maybe learn some assembly. I know I tried to avoid it in school. They don't teach a lot of it here, but definitely need some Python and C++. Get taught here a lot.
Be able to learn new languages. That's probably the biggest thing. Understand how they work and be able to pick up new ones, because there's always something new coming out.
Absolutely. Okay, second question. The theme of the questions I'll be asking are related to experience and skills necessary in cybersecurity. And there are a couple of questions specifically related to entry-level positions and what are some skills I need and what level of expertise do I need to have in those skills to be successful at an entry-level position at a cybersecurity job. So since you're up on the screen already, Jason, I'll just go right back to you.
Sure. Reiterate the last one, Python, super helpful. So I'd say one of the most common entry-level jobs is a SOC analyst, where you're triaging alerts and doing all that kind of stuff. And so in that, being able to script is very important. Being able to bring data together, get it quickly. So scripting is very important. The other side of it is automation is very important as well. Like you could set yourself apart. I like to say I like lazy SOC analysts who don't want to do the same thing twice. They just want to automate it. And so then it's out of their way and they can do something new. So that's one. The second way is there's, going into bug bounty or attack and penetration. One of my favorite security certifications is the OSCP and the OSCE. They're the Offensive Security Certified Professional. It's actually a really, really tough certification, but that teaches you to hack into almost anything. And that's another way to get in is finding some bug bounties and finding bugs and reporting those. And you can build your resume. You don't even have to have a job. You can get paid for doing those and then get into like that sort of offensive security side of things.
Great, thank you. How about you, Matt?
Yeah, places I've worked, things that are useful. So binary analysis experience. So using tools like Ghidra or Binary Ninja. That also goes back to being comfortable with reading assembly. Vulnerability research tools like so that it can help automate the process of vulnerability research. So there are two techniques that are popular. One is symbolic execution. There's a framework called Anger that does a lot of things, including symbolic execution. It's ANGR. That's free. It's the main folks are at Arizona State University and UC Santa Barbara that are developing it. And then fuzzing. There's a bunch of options there, but probably the most popular is AFL++. And then being comfortable using debuggers. So GDB and WinDbag are the would be the two, and I guess LLDB, which is similar to GDB, but different set of commands. So that's useful for, I mean, of course, debugging program that's not working, especially if you've written something in C or C++. But it's also useful for dynamic analysis of a running program. So being able to inspect registers in memory.
So for an entry level position, do you think someone needs to have deep understandings, or at least just kind of know what's going on with, you know, debuggers, binary analysis, or like what level there?
Yeah, so I would say all those would not be expected, but at least decent knowledge of one of those things. So, you know, comfortable in Ghidra, but maybe hasn't done a ton of stuff in GDB. Has, you know, used Anger, but has never done any fuzzing, but has only used Anger and done symbolic execution. I'd say those are, yeah. So and obviously for entry level, like no one's expecting you to necessarily be an expert, but having familiarity and being able to demonstrate that you can use those tools is, I mean, that's basically a slam dunk. I don't think I've ever seen. I don't think there's ever been an interview that I've been involved with in industry where someone that didn't have at least one of those things wasn't given an offer unless there was some other like wild red flag.
Good to know. How about you, Tim? How do people, what skills do they need to get their foot in the door at AFRL?
You know, so I'm having a tough, so I'm trying to think. So we get that question a lot from the interns, right? So when we're interviewing candidates, they'll ask, what can I study up on, you know, before I get there? The first thing we'll tell them is, you're at this interview and we selected you for this process because we've reviewed your resume, we've reviewed your transcript, so we know you have the skills we're looking for. So my answer to this is more of the qualitative part, which is definitely you want to develop your writing skills, your speaking skills, and you want to be able to work as a good team member too. I mean, that's a big one that comes up a lot. Over.
Yeah, I think from my understanding of the Maven internship, those are some of the skills that they'll get to learn there: communication, scientific process, that kind of stuff. All right.
Right. Yeah. So yeah, 60% of the time they're doing the research and development, and then probably 40% of the time they're doing those qualitative skills. Yeah.
And Andrew, how are you?
I want to echo mostly what Jason said and some of what Matthew said. Scripting is important. I mean, I'm a past master of scripting. I, you know, wrote entire automation systems in Bash and in Tuckle. For some reason, I can't stand Perl, but the point is that if you are, you know, sort of doing in life, you've got a project manager, a whole bunch of data in front of you, and you again need to crunch the data and do something useful with it. It's way faster to do that with a script than it is with, you know, writing C code. And if you're doing any sort of, you know, playing with the cybersecurity, you see something, you've got your own lab, thank you, you're not going to do this out in the wild where you're going to get arrested. I've seen too many students do too much stuff out. You know, why are you doing this out there? You are going to get arrested. Pull it back in-house. Do your proof of concept exploit. You're going to do it in script 9 times out of 10 because it's just more productive. So yeah, absolutely scripting. And on the attack side, not everybody is going to be a penetration tester. If you have that as your career path, you probably know it already because you've been hacking for the last 7 years already. But everyone who wants to be effective in the cybersecurity space has to understand how to attack things. So you don't have to learn enough to be a pen tester, but you have to get your hands dirty and read about attacks, try some of them out on your own, in your own test bed, thank you. You cannot defend a system unless you have a solid understanding of how the bad guys are coming after you.
What would be your top one or two resources for finding current attacks or old attacks, or learning about attacks that are out there?
That's a good question. I mean,
Or any other
the turning point for me was I paid a large sum of money to SANS to take firewall training, you know, 3/4 of which was explaining how to break through firewalls and then adjust the rules yet again to try and stop that attack path. Okay, now here's another one. Oh, I came away from that training, you know, 6 days of it, convinced I was going to close all of my online banking accounts. So that was an eye opener. And the other one that helped enormously, now I'm on the OT side, it was the Department of Homeland Security at the time, now it's CISA. They have red team, blue team training. And that was huge for me in my own career. In terms of resources out there, there's books, there's, shoot, what's the name of that? There's a whole series on how to hack, basically.
Hacking Exposed, probably.
That's the one, thank you, Hacking Exposed. Play with their examples, learn how to do this stuff. At some point, get hold of a Metasploit distro, a Linux distro, and play with that, again, on your own little test bed. Again, that was an eye-opener for me.
Yeah, I was gonna say Kali Linux. Get familiar with that. That's usually what most pen testers use. And then if you want to find the latest and greatest, go to CISA, CISA, and they'll have the latest vulns that are out there. And then, or CVE, MITRE has the list of all the vulnerabilities that are basically out in the wild, and you can look those up, and you'll find exploit code. It's usually pretty easy to find it through CISA or those sites.
That's right. And I would go to CVE as well, common vulnerability.
Yeah, that's the MITRE one. Yep.
That's the MITRE one. So, you know, Google it, find it. They've got thousands of vulnerabilities there, many of which have proof of concept exploits attached. So again, you can look at the code and get an understanding of what it does.
Great, thank you. And Dr. Smith, I'll say that because it's different from Jason, it's less. Or Jessica?
Yeah, I start calling me Dr. Smith and I start looking around for my professors and trying to remember if I did my homework or not.
Okay, we'll stick with Jessica.
I'm going to answer this a little bit differently because I am in the unique position where I'm not usually looking for technical skills. You've got to have those. That is the foundation. You've got to have those. But what I'm looking for when you come on as a new hire, call it a spark, call it interest, call it passion, call it I don't know what. But I'm looking for the person who says, yeah, I actually want to be here. This is not just a job. So I can hire people for it's just a job. They show up, they go home. That's nice. I want to be working with people who have a passion for this. People who actually enjoy, you're not going to enjoy everything, but you enjoy at least some of your day at work. I don't want to work with people who are miserable. That makes it miserable for me. So I'm looking for, say you're a software engineer. I'm looking for the software engineer who has a very active GitHub. They're out there contributing to some of the open source projects. If you're on the network defense side, you've got those CTFs. You've gone to PRCCDC. You've gone to CyberCons. You've done that type of thing. If you're into research, that you've got a couple of papers published out there, maybe not first author, but you've actually shown that you're interested in this beyond the classroom. Because when a resume comes across my desk, almost every cybersecurity recent graduate has this same set of classes. And it's like, great, y'all took the class, wonderful. What were you passionate about? What did you enjoy doing? Was your thing crypto? Are you a math nerd and you really, really want to dig into crypto? Great. Find some way, whether it's a project, whether it's outreach, find some way of showing those type of things on your resume, because those are what I'm looking for, is somebody who has a passion, who actually wants to be doing this and because they're going to be successful. Cybersecurity keeps changing on us. The stuff I studied when I was in school, a lot of it is obsolete at this point.
Sorry.
Hey, it's the way this goes. It's part of why we chose this field. It's why I chose this field. It's because I get to learn new things every single day. There's always something new coming out. So I want to find those people who are passionate, interested, and want to keep learning about whatever they're passionate and interested about. And that can change. That's not gonna say you're pinned into that. I started out as a computer engineer looking at architectures. That was what my degrees were focused on. I do a lot of project management now. I do publicly available information entity research. We do SBOM, HBOM. So it's not saying that you have to do that for forever, but come in and show me that you've got a passion and that you're willing to dive in and really enjoy something. That's what I'm looking for out of a new hire.
Awesome. Thanks.
If I might jump in real quick. Sorry, I'm taking too much time, but there's a difference between talent and skill. Skill and knowledge you can acquire if you work hard enough. That's, you get that. Talent to a degree is what you're born with. It's what interests you. You use the word passion. I use the word talent. If you like something, you're gonna get better at it because you like learning more about it. So try to find something you like in the field. It doesn't have to be what you're going to do all day long. No one does the same thing all day long. But if it's a piece of what you're doing, you're going to get better at that. And the hiring people understand that. Everyone here who's hired people gets that.
Thanks. Yeah, I think we got time for another question. I'll kind of wrap a couple related questions together for this one, just for time's sake, though. In terms of qualifications, like college degrees and certifications, maybe you could speak to, what degrees you had going into your career, whether that started out in cybersecurity or not, and how valuable those degrees were for you in cybersecurity once you got there, and also if there are any certifications that you picked up ahead of time or along the way that have helped advance your career as well. So degrees and certifications. Let's start with Matt.
So coming from a university professor, maybe you don't expect this, but some of the best colleagues I've ever worked with never went to college, or at least don't have a degree. They might have taken some classes, but they didn't graduate. So I don't think a degree is necessary to be successful in the field. But I think that's a good thing. That said, I think a CS degree or a related degree can absolutely set you up. You would be exposed to fundamentals that someone that's coming later to pick those up is going to have to struggle through. It is absolutely useful, but not required. I've seen I've also had colleagues that did like physics degrees, and I think any kind of degree, anything that has a flavor of mathematics to it, is going to be useful, because at least for the part of the security world that I work in, because it's all about problem solving. So if you have tools to think about things in a formal way, if you're comfortable doing that, then you're going to excel when you're doing things like hunting for vulnerabilities.
Great. Let's hear from Tim next.
Yeah, I mean, one thing I would say is a strong math background. We have mentors and others that when they're looking for candidates, they won't even consider candidates that don't have a strong math background. So particularly calculus, they want to see good grades in calculus. Over.
Jessica.
It's a good thing my job does not require a good grade in calculus. I passed. I think that's about as much as I can play. I'm gonna be a little bit of an oddball again. The lab does not usually hire folks who don't have a degree, not necessarily a cyber degree or a computer science degree. But to get on with the lab, you do have to have a degree. Now, that is because we are very research oriented. That does not mean that having a degree is necessary for all jobs in cyber. When I'm evaluating folks, though, I look for degrees and certifications that are backed up by experience. or backed up by passion or knowledge or whatever you want to call it. If you have a long list of certifications and no practical hands-on experience, great, you can take a test. That doesn't make you useful in my office. That doesn't make you useful as a part of my team. I see a lot of students doing that. They're just, oh, I gotta take this cert, I gotta take this cert, I get it on my resume. Yeah, it's nice because it makes a nice checkbox. And HR will, the HR folks get first dibs to look at incoming resumes. And having that box to check means you get past HR. Great. The problem is that when you come to me and I actually ask the technical questions, I ask how do you think type questions, those aren't the type of things that you're gonna get out of a certification. So certifications, yes, I have my CISSP, I have the CSSLP, and I think I've still got my A+ cert all those years ago. Getting those is valuable because it's something you can put down on a resume that shows you have a skill. That will only get you in the front door. Getting through an interview, you've got to have the skills to back it up. I see too many times it's not there. So degree, yes, and I am actually pretty solid that I like to see some kind of computer science, cybersecurity, or electrical engineering degree, because you need to know the fundamentals. I don't expect that you're gonna have a great knowledge, but when I walk in and say, okay, well, how does encryption work? How does public key encryption work? What is CIA? What's the CIA triad? And if you haven't got those basics, it's hard to build up. It puts people at a great disadvantage. So degrees, yes. Do you need to go for your PhD? If you do, fair warning, if you don't go in with a mental illness, you'll come out with one. It's not necessary for cybersecurity. I'm actually the only one in my group that has a PhD. Everybody else has bachelor's and master's. That's completely acceptable. I think I've wandered around your question.
Yeah, I think you hit the main points there. I was gonna ask you, when it comes to further degrees beyond bachelor, what would be the benefits of that for anyone thinking about getting, a graduate degree of, what would be the benefits of a place like PNNL of having one?
It proves to us that you can do research. There's a different way of thinking that you have to kind of jump into if you're willing to do research. I love interns because the interns I get, I'll give them problems that I don't necessarily think can be solved. I'm looking for interns who can take those problems and figure out, okay, no, there is this solution to it because they're thinking out of the box. They're thinking out of the back of the book. There is no right answer. There is no wrong answer. There is no documented answer. You can't flip to the back of the book and get that -12 is the correct answer. So that's kind of where I take that, is that I'm looking for those students who can think out of the box and take it down that path.
Okay, great. Let's hear from Andrew next.
Sure. Not research, but industry, a degree helps. No guarantees, but it helps. A graduate degree helps. No guarantees. If you have it in you, get an MBA so that you do a technical degree first. I mean, my first degree was in applied math. I spent 7 years in industry. I went back, I did a master's in computer science. A graduate degree helped, I think. It made me sort of more promotable. Again, no guarantees. An MBA, I think, would have helped even more. Because the more responsibility you're given, the more you're expected to look out for the needs of the business, and the MBA credential, and to a degree, the training helps. I've learned a lot of stuff the hard way, slowly, over the years. And in terms of certifications, they help too. Now, I'm a little bit out of touch in the last 5-6 years, but I remember 10 years ago, I had a gentleman ask me at a conference, should he get certified? I said, oh, well, what do you do now? I'm a student. What do you study? I'm doing a PhD in cybersecurity. I said, wow. And he was asking me, do I need a CISSP? And I said, a PhD in cybersecurity is so much more than a CISSP. But I said, today, almost nobody knows that. None of the people hiring you know that. Get the CISSP.
Good to know. Thanks. And yeah, Jason.
All right, I'm going to say earmuffs to all the professors here because I'm going to say one thing that'll probably make them a little unhappy. So if for an entry-level job, if you have a bachelor's degree, if you have a master's degree or a PhD, I'm going to pay you the same. You're not actually going to get more money. So sure, it could help you get to the top of the resume list if you've got a higher degree, but it doesn't necessarily mean that. Same thing for certifications. Like what Jess said, if you got 15 certifications and no experience, I'm still going to pay you the same as somebody that's an entry level with none of those certifications. And then again, kind of referencing what Jess said a little bit earlier, is actually more important than certifications. Is I want to see that you're constantly learning. And I think Andrew and everybody has said this. It's like, show that you're interested and passionate about constantly wanting to learn in the field. It doesn't actually need to be a certification. It could be, I've been researching this and trying this out in my lab, and then I've been doing this. And if you could like whiteboard it and show me, like that's just as cool as a CISSP, better, more cool than a CISSP. So the constantly staying like, oh, I've been looking on what's the threat models around AI, around LLMs right now, and I've been thinking about this. And so having that kind of, we call it in the corporate speak, it's called a learner mindset, is just the constantly learning is actually more important to me. However, if you want to hear the certifications, a lot of people have the CISSP. My favorite one personally, and remember I come from a attack and penetration background, is the OCSP. But it's not easy. It's literally a 48-hour window test, and you got to do everything within 48 hours, and it's actually pretty rough, but it is a very good certification. Again, will I pay you more for it? No, but it gets you in the door.
Yeah, when it comes to demonstrating that ongoing learning, what are some good ways to do that? Should an applicant come to the interview with, you know, a GitHub repo that they're going to boot up and show you during the interview?
That would be awesome. Something that a GPT-4 can't do and give the answer to, or showing because believe it or not, that's actually becoming more and more common that we're seeing people reference that and leverage. But the showing me or even whiteboarding on a screen, being able to show me like how you're thinking about this new problem and thinking about new things, and just showing that you're learning is kind of, because I think somebody else referenced like the programming language you learn now in 5 years are going to probably be to something totally different. So you need to be able to just keep learning. It's just going to constantly change. And I want somebody that's wanting to keep learning, because the information's 5 years ago, it's going to be antiquated, and I'm going to be wanting what's the now that you're learning, and what do you feel is the latest and greatest, and showing me your code, showing me what you've been working on. That all is great as well. Repos, we definitely look at, if you put those in there, we look at those repos. And so, yeah, that's how I would kind of showcase that.
Yeah, have a pet project, contribute to open source. Yeah, definitely.
Yeah. Yep.
Excellent. Well, Asifa, we've got about 10. Wait, first of all, was that everyone? I think I got everyone on that question. Well, we've got about 10 minutes left. What do you think, Asifa?
So I think we should maybe check if some questions are there from the audience for this distinguished panelists who have a lot of wisdom and insight to share. So maybe we use a little bit of time for that. Otherwise, I would suggest that we stop a bit early so that you get a break before the next session comes. So why don't you check the room if there are any questions?
Any questions? This is a great opportunity to ask some people from industry, people from the types of jobs you're probably going to want to have, 10, 15 years from now. No? Well, doesn't. Oh, we got one.
Oh.
Yeah.
So with a ME and EE background, how do you see the mechanical component side of stuff with PLCs and PCBs and that kind of design? How do you see that being incorporated more with cybersecurity?
That is foundation of vast majority of the cybersecurity that I do, because I do cybersecurity for industrial control systems. I do cybersecurity for the power grid, for water, wastewater, for satellites, all of those things, unless we understand the mechanics of that thing, the real world. It's the computers are largely the same, amusingly. How they interact with the real world, though, is what changes. If you want to go back, look at Stuxnet. Yes, I know it's ancient history now, but we saw Stuxnet all across Europe in different systems. It was in all sorts of Siemens Z7s. They were all over. But until it hit that one P7 that was connected to a centrifuge, it was irrelevant. Once it was connected to that centrifuge, all of a sudden you have massive problems. So understanding how the physical reality works with the computer is critical when you're talking about national security level systems. And I jumped in on that. Anybody else want to?
Were you able to hear the question all right online?
Yeah, I'll jump in as well. You know, Waterfall serves the OT space, the industrial automation space, and you know, an initiative that I'm tracking very closely is Idaho National Labs cyber-informed engineering, not CCE, not consequence-driven cyber-informed engineering. I see that as a subset of the bigger picture of cyber-informed engineering. And what's, you know, one of the emphases, it's a big program. One of the things in the program is the role of the engineer has been, let's call it underemphasized historically in cybersecurity. I mean, engineers study the physical process, they study automation, they study safety, because when public safety is at risk in large projects, I mean, every powerful tool is also a weapon. The more powerful the tool, more powerful the weapon. And a large power plant, you know, a passenger rail switching system, these are very powerful tools. And engineers, since the beginning, where did the word engineer come from? You know, it was the people driving the trains. What was their number one job? Don't hit another train. That was their number one job. There was only one track across most of the land. Public safety, worker safety has been what engineers do since the very beginning. And engineers are very good at that, dealing with, you know, what's the threat of an earthquake causing an explosion in the refinery and killing people? What's the risk of a hurricane coming through and damaging all my equipment? How do I design the physical system to address those threats? What's been neglected in too much engineering training and too much engineering practice is the cyber threat, and that cyber threat is increasing alarmingly. And the time has come for the engineering profession to stand up and say, we need to address that threat in our designs. And there's two ways to do that. One is physical tools and designs that engineers have that don't exist in the IT space. And the other one is, of course, the IT tools that do exist in the IT space. To me, the role of engineers in cybersecurity for industrial automation has been neglected, and this is the big change that's going to come in the next 10 years. And, you know, the change is going to come. It'll be a change for the better. There was another question I saw while I have the floor, while I'm on the topic, talking about the future. For 40 years, we've been deploying more and more automation, more and more targets for cyber attacks in businesses and in physical automation. For 40 years, we've been connecting that automation, creating more and more opportunities for attacks to reach those targets. Neither of these trends is reversing in the next 20 years. The cybersecurity problem is going to get much worse before it gets better. The industry will have ups and downs. There will be layoffs. There will be hiring again. But the future of cybersecurity, the world needs more cybersecurity, and the world needs more engineers in the industrial space involved in cybersecurity.
Great,
Yeah,
thank you. Yeah, go ahead.
I was just gonna say, if we wanted to give people a chance to answer that question, the question was, you know, what do you think the future of cybersecurity looks like? You know, in the last 6 minutes here.
Yeah, that was what my intention too. So since the question the student asked was kind of related, and Andrew did a good job on that one. So Jason, team, you may think about it while Jason answers it. How do you see the future of cybersecurity? What is the biggest thing that's going to happen in the next 10 years or so?
Sure. Well, I mean, right now, the kind of the cutting edge that like my company and a lot of companies are working on is how we're going to use LLMs, how generative AI is going to apply to cybersecurity. And right now, like my company did a survey of like 1,000 CISOs of like the Fortune 500 plus, like a whole bunch of other companies. And right now, and maybe it's because we're cynics, but most CISOs think it's like 80% think that AI is going to help the adversary and make phishing and make everything easier for them to be able to attack us. And I really think that the job, and of course this is coming from we sell security software, so we've got to do better than that 20%. We've got to think about how do we use LLMs to make either our software more secure, or because I know everybody uses Copilot, and unfortunately Copilot makes a lot of code with vulnerable pieces in it. So we need this secure by default, and we need to be able to defend better. Is it through automation that AI can do some things? Generative AI, can it help us respond quicker to incidents? And we've got to move up that 20% and we got to move it to where it's like we can leverage this kind of that new technology to support us. And then the second one, quantum is going to come. Quantum is basically that quantum computing is going to be able to basically factor any kind of the crypto that we have right now. And so we're going to have to switch to quantum resistant algorithms. And you're starting to see a little bit of that. But I think what's going to happen is in the next 10 years, it's going to be a date that's going to happen, and it's going to go public. And the whole world's going to have to switch off of all the crypto. And it's going to be a huge, huge, huge effort. We keep talking about it. Hasn't happened yet, but we need to have that, we call it quick crypto resiliency or agility to be able to swap out, everything that we have.
Thank you very much. I echo that very strongly. Jace, let me go to you. Future of cybersecurity, what do you see the biggest things that's going to happen?
I think that cybersecurity is right now it's an own independent thing. It operates very much in the IT space, even with all that we've talked about the OT. I think we're going to see over the next 5 to 10 years, the global socio-political relationships, environment, however you want to look at that, it's going to change. And cybersecurity will shift from being a tool to becoming a weapon. And we can either choose to think about that and plan for it and create our defenses appropriately, or we can choose to ignore it. There are other nations in this world that are very much already looking at this as the next battlefield. And I know that there's been a lot about that, this, that, but that's where I see this going, is that the open internet, the open communication, the open exchange of information that we see a lot of right now. I hope it will continue. I hope we can continue collaborating across country lines. I worry that that is going to become a point of contention, though.
Thank you very much, Jess. We've got about a minute or two, so very quickly, team, you want to add anything on how you see cybersecurity going in the future?
I mean, I just know in general that the need for cybersecurity professionals is going to grow, and I know that the reason that Viceroy exists is because there is a gap between the certified professionals that can do the job and the job openings, and we're trying to fill that gap. Over.
Thank you. Matt, I'm going to take you as the people who are behind this teaching, and that's the business we are in. And so let me stop here so that the people would get enough break before the next session comes. I really, really appreciate very much you taking the time to share this. It's almost 2 hours, and I know how valuable your times are. So the students, on behalf of them and on behalf of this program, really want to say thank you very much for this time and for all the great things that we have discussed. It's recorded. The students will have access to it later on. And those who have had it, not had a chance to participate today can learn from it next time. And team, the students that are coming your way, you have more chance to interact with them. And thank you for all that you do there. So I think we're done. James, unless you have anything else for me to mention. I know there is a session coming right now at the top of the hour, so they will have a 15-minute break. So if not, then thank you very much.
Yeah.
And
Thank
you
you.
can clap your hands there in the audience. I think they can hear you. So.
Thank you very much to all of our panelists.
Pleasure.
Right.
Thank you.
All right. Thank you.